All right, welcome back, everybody. We're going to continue with Unit 4, Transforming Parabolas. A lot of this work is review from when we transformed absolute value graphs. So it's a lot of parent graph stuff. So I'm going to zip through this and make this short and sweet. Just some review of standard form of a quadratic is ax squared plus bx plus c. A cannot equal 0. That's because if a is 0, we don't have a quadratic term. Therefore, we don't have a parabola. And the graphing vertex form, okay, is using AH and K, and our vertex is always at the location HK. More review stuff. The graph of a quadratic function is called a parabola. The axis of symmetry is the vertical line that divides the parabola into two identical halves, written as x equals wherever your axis of symmetry is. Okay, this is always going to be at the h value, the x value of your vertex. The vertex of a parabola is the point at which the parabola has its max or min, and is also the point that intersects the axis of symmetry. So just a couple definitional stuff there. Graph shifting steps. Again, we're going to sketch the parent function. Okay, put our 5 points there. If we have an a value, okay, we're going to multiply by it, the y coordinates by that to get our new points. And then obviously move it around however far up, down, left, or right we need to be. Okay, so our parent graph, which is y equals x squared, I'm going to plot our points here. Okay, so there's our quadratic, most simplest form of a parabola, y equals x squared. All right, that's the graph that we're going to continue to move around, stretch, and compress, etc. Okay, so one thing I always like to do in my classes is just kind of dissect to see exactly what are all of the transformations that this graph is having. Most people state the obvious. Okay, here our graph is going right 2 and up 3 with a vertex at 2, 3, and our axis of symmetry is at x equals 2. All right, the a value out here tells us something too. Okay, that is positive, therefore it opens up, and also this a value equals 1, so there is no vertical stretch or compression. All right, so all the observations here on the left should reflect on our graph at the right. Okay, so you could graph your normal parabola. Okay, our parent equation here. All right, so if we took this graph, okay, all right, and we duplicate this, all right, all we have to do is slide this over to the point 2, 3, and that becomes our new parabola. Okay, there's no stretch or compression factor. Everything just slides right 2 and up 3, just like our observation stated. Okay, here's one where we do have an a value of 2. So real quick, let's just go through and dissect. Opens up. This one will be a vertical stretch. This is going left 4 units and down 6 units, where your vertex is -4, -6. And our axis of symmetry is at x equals -4. Okay, that's something we forgot to graph over here. Our axis of symmetry is at x equals 2. Okay, usually we represent that with a dotted line. Okay, so our normal parabola, okay, we can take this graph up here, our parent graph, all right, graph that one. All right, if we duplicate this graph, all right, this is going to slide left 4 and down 6. However, we need to vertically stretch this thing. Okay, so as you look at your staircases here to go from point to point as we move, counting by ones on the X, it goes 1, 3, 5, 7, our staircases. Okay, that's what we're going to multiply by our A value, that vertical change. All right, so now, instead of, that's still going to be our vertex there at -4, -6, but instead of climbing up 1, okay, we're going to climb up 2 and out 1. Okay, and then instead of climbing, I'll write it down here. These are the staircases. Okay, so we're going to multiply those by 2 because that's our A value. All right, so we're going to climb 2, then 6, then 10, etc. So 1, 2, 3, 4, 5, 6, out 1, 3, 4, 5, 6, out 1, and then up 10, which we're off the paper. Okay, we're off our grid. All right, so we can see that that's definitely vertically stretched. It's increasing faster, which makes the parabola a little skinnier. Okay. Oh, axis of symmetry at x equals -4. Okay. This graph right here, I'm just going to go right after it and just plot this equation instead of duplicating and sliding around. I think we're to the point where we can handle it, I hope. Okay, so this one's going to open down. It's going to be vertically compressed. We went right 3 and up 4, which means our vertex is at 3, 4. And that will also be our vertical line of symmetry at x equals 3. All right, so from our parabola, we said before our staircases were 1, 3, 5, 7, etc., but we're going to multiply by a half now. So each time we go out 1 unit, all right, we're going to go down because our parabola is opening down a half a unit. So we're going to go over left and right each 1 unit, but down a half a unit. And then as we go out again 1 unit, we're going to go down 1.5 units. And from there, go out and down 2.5 units. Okay, and then finally 3.5. Okay, so all this is fine and easy when our equation is in graphing vertex form. But you can see here, peeking at the next question, what happens when it's not in graphing vertex form? All right, this is where your idea of completing the square comes in handy. We can go from standard form to graphing vertex form pretty efficiently. All right, so we're going to set our, just look at the right side of the equation here. All right, and we're going to complete the square. Move the 8 over, do b divided by 2 squared. So -2 divided by 2 is -1. 1 squared is 1, so I'm going to add 1 to both sides. Okay, this right here is my perfect square, x, and then just b divided by 2, which is -1, equals 9, and then I'm going to subtract my 9 over to get it in graphing, vertex form. All right, so here we can do all the same observations we did before. Positive, so it opens up, no stretch or compression, right 1, down 9 units, vertex is 1, -9. with the axis of symmetry at x equals 1. So 1, negative 9, and then we can use our staircases, up and out 1, up 3, out 1, up 5, out 1, and up 7. Okay. And don't forget, we can use the idea of symmetry also. The point on the left should match the point on the right side because of our axis of symmetry here at x equals 1. So this is yet again another reason why completing the square is beneficial and useful, not only when solving quadratics that are not factorable. We can solve by using square roots, but it also sets us up to give a pretty neat and accurate graph when it's in graphing vertex form. Pretty efficient way. Okay, we don't get all that information in standard form. The only thing standard form gives us is our y-intercept here, is the c value. Okay, but from the vertex, and we know the pattern of the graph, how a parabola behaves, we're able to get a lot more out of this form of the equation when it comes to graphing. Okay, let's try another one here. So we'll just set that equal to 0. We'll add the 1 over to both sides. All right. Do b divided by squared, b divided by 2 squared. So 4 divided by 2 is 2. 2 squared is 4. This becomes our perfect square. X plus 2 quantity squared equals 5. And then we subtract 5. And we get y equals x plus 2 squared minus 5. Same thing. Opens up. No vertical stretch or compression. Left 2 and down 5. So your vertex is negative 2, negative 5. And we can do our 1, 3, 5, 7 pattern from there. And then draw our axis of symmetry at x equals negative 2. Okay, and we can see again, like we said before, there's your y-intercept. So we can always confirm our y-intercept here, negative 1. Okay. All right. One more problem for the day. Writing the equation in vertex form when we know the vertex and any other point. Okay. So this is actually a lot simpler than it looks. All we do is we know that the vertex stands for h and k in our graphing vertex form. So you're going to substitute that in for h and that in for k. All right. So it's going to be x minus 2 quantity squared minus 3. And then we know this other point over here. Okay. This other point is 5, negative 1. So all you're going to do with that point, that represents x, that represents y. So you're going to substitute the 5 in for x and the negative 1 in for y. All right, I did this in 2 steps just to show the difference between hk and x and y. Some of you are going to get good at this and be able to substitute it all in one shot. I would just warn you, be careful. All right, make sure you're plugging h and k in from the vertex, and then x and y, your other known point, goes in for x and y. All right, so let's finish this thing off. So negative 1 equals a times quantity 5 minus 2 squared minus 3. All we do is solve for a. Okay, so it becomes order of operations. So I get 2/9 equals a. Therefore, your equation is y equals 2/9 times the quantity x minus 2 squared plus 3. So we substitute our h and our k back in. All right. If we plot this, 2, -3 is our vertex. It's supposed to go through 5, -1, all right? Which means on the other side, we went up 1, 2, 1, 2, 3, so 1, 2, 1, 2, 3. Okay, that would be another known point. All right, we can confirm this graphically. If we pull up our calculator quick, let me do that. I just want to show you guys that you can clearly see if you type in your equation here in y equals, that you can see the symmetry in your table where 2, -3, got a mistake over there, should be -3. 2, -3 is your vertex, and it does contain the point 5, -1. So 2 ninths times the quantity x minus 2 squared minus 3. And we can look in our table and see, gotta go in the table settings. Where's my table settings? Okay. So we should be able to see 2, -3, okay, right here is the middle. And then as we go above and below, the points are the same. -2.77, -2.11, 5, -1, and -1, -1. We recognize the symmetry in the table. So we're looking for that is our vertex, that's our middle, and then our symmetry is based off of that. So 5, -1 is there as a point, so we know that our A value is correct. Okay, so we'll practice a couple more of these when you come back in class. But again, a lot of it is review with the exception of this last question here where all you're doing is substituting in for HK, X and Y, solving for A, and then rewriting your rule. Okay, guys.